All right, so let's talk about what that means. So we are looking at 6.2, number 2C, and we're going to find the angle between those two vectors. So you have already done the dot product. So we know that the formula we're going to use is the dot product divided by the magnitude times the magnitude. So you already did the dot product. The vectors are 6, 4, and 2, negative 3. And when you did the dot product, you got 0. Now you can go ahead and find the magnitudes if you want, but they aren't really going to matter this time because isn't 0 over anything just 0? So how do we find the angle? We second cosine this fraction, but that fraction was just 0. Oh, so theta is 90 degrees, which means these two vectors have a special relationship. If they make a 90-degree angle, they are, what do we call that? A right angle. What do we call that when two lines intersect to make a right angle? We call them what? What's the word we use for that? Perpendicular. So in geometry class, we said these two vectors would be perpendicular to each other, right? Because they form a right angle. Well, new vocabulary word. In vector land, we don't say perpendicular, we say orthogonal. So these two vectors are orthogonal. Now, just for fun, let me show you something. If I drew a picture of this vector, I'd go right 6 and up 4, right? So the slope of this vector would be 4/6 or 2/3 because it goes up 4 and over 6. That would be the slope of that vector. What about this one? What does this one do? He goes down 3 and right 2. Look at those two slopes. One of them is 2/3 and the other one is negative 3/2. What did we learn in algebra class about that? If they're opposite reciprocals, the lines are perpendicular. So these two vectors have opposite reciprocal slopes, so of course they're perpendicular. What happens when vectors are orthogonal or perpendicular? Their dot product works out to be 0. Now, right now, I can tell by the looks on your faces, this is just not a stunning piece of information for you. But in 3 dimensions, kids, that idea is huge. Because in 3 dimensions, there is no slope. Slope is rise over run. If you put a 3rd dimension in there, then you can't talk about slope anymore. So if you have 2 random 3-dimensional vectors here in the room, and you want to know if they're orthogonal, the only way to tell is to do the dot product. What happens to the dot product if vectors are orthogonal? You get 0. Okay? So you're walking down the hall, somebody says, hey, are these vectors orthogonal? All you have to do is a quick dot product. If the answer is 0, yes, they're orthogonal. If the answer isn't 0, then no, they're not. Okay, one more of those, and we're on to the next thing. All right, so our vectors are negative 2, 4, and negative 5, negative 2. We want to find the angle between them. So our formula says we need the dot product divided by magnitude times magnitude, right?
break it down into?
No, I wouldn't do that because the question is not asking me for the actual cosine value, so I'm just going to type that number into my calculator. So what's my dot product? 10 minus 8. I think she's right. 2. How do we do a dot product, Bo? X times X plus Y times Y. Okay? Alright, now, what are my magnitudes? Well, Olivia already said the magnitude, that first one is root 20. Her question was, should I reduce that? And my answer is no. Just leave it. This one is root 29. So I have 2 over the square root of 580. How did I get 580? Multiplied my 20 and my 29. And now I will type that into my calculator. That is not the answer. That's the cosine, right? So theta equals second cosine 2 over 580, square root of 580. $85.24. You okay with that?
Yes.
All right, we're almost done, folks. Hang on. Struggle through. To answer the next question, you can absolutely use slope if you want. Because if things are parallel, what do we know about their slopes? No, if they're parallel. If 2 lines are parallel, their slopes are the same. If 2 lines are perpendicular or orthogonal, their slopes are opposite reciprocals, right? So all of these questions can be answered with that in mind. What is the slope of V? The slope of V is 1/2. This is 4. How do you know that? Because the vector is going to right and up 1. And isn't slope rise over run? So the slope is 1/2. What about U? What's the slope of U?
2.
4 over negative 2, which is negative 2 over 1. Tell me about those 2 vectors.
They're opposite and reciprocal.
They're opposite reciprocals, which means these guys are orthogonal. What happens if I do their dot product? I get 0. All right, let's look at B. What's the slope of V? 1/2. Let's look at U. What's the slope of U?
1/2.
Okay, what do we know about these 2 vectors then? They have exactly the same slope, so they are parallel. What about C? What's the slope of V? 1/2. What's the slope of U? Negative 7/5.
Neither.
Nothing going on there. They're just 2 random vectors that intersect, and that's it.
That is easier.
What about D?
Probably either.
The slope of V is negative 1/3. What's the slope of U? 2 over 2, which is 1. That's another neither. E, negative 1/3 is V, and U is negative 2/6, which is negative 1/3, so those are parallel. In F, V is negative 1/3, and U is 6/2, which is 3 over 1. Those guys are perpendicular. let's use the vector word since we're talking about vectors, so we'll say they are orthogonal. Now, just to reinforce that idea from before, if you do the dot product in letter F, you had better get 0. Notice you do. Because if vectors are orthogonal, their dot product is 0. Okay. Now, one more problem. Oh, stop it! You guys, this is your favorite class of the day. Quit acting like you can't wait to escape. What in the world is happening here?
Math.
You have seen these before, believe it or not. Way back in chapter 1, we had these things called parametric equations. These are referred to as parametric equations. Now, I have 2 of them. Look at the directions. Eliminate the parameter. T is called the parameter. So we want to eliminate the parameter and write a single equation so that we can identify the curve. So in other words, I could type those equations into my calculator and graph something. And next time we'll do that. We don't have time to do that right now. So we're just going to we're just going to eliminate the parameter and write the one equation. Anybody remember how to do that? We actually did this earlier in the year. Anybody remember it?
Equals.
What?
T equals.
Exactly. Take one of your equations, and this one would be the easiest, and get T by itself. So would you agree that this equation could be rewritten as T equals x minus 1?
Yes.
Then we'll take this and substitute it in here. So y equals 3 minus 2 times x minus 1. So we're doing a substitution process. Get T by itself and then plug it into the other one. So when you clean this up, I got y equals negative 2x plus 5. Identify the curve. If you graphed that, what would it look like?
You start
a
at
line.
5.
It's a line, and yeah, it's going down because it has a negative slope. So identify the curve, it's a line. What if we had come out with an x squared? Then what would it be? A parabola, right, exactly. Which will happen tomorrow when we do this. Vectors and matrices have their own language. I have no idea why. There's probably a reason. I don't know what it is. All right, folks, I'll see you tomorrow. What happens tomorrow? We have a quiz.